Alright, so we talked about this yesterday. So we ended here yesterday, by the way. For whoever's playing at home, Straveler, feel better if you actually watch this video.
Probably not.
So it is 125, and we're still on factoring quadratics. We will probably get into 12.6 today, but on the... Yes?
125 and we're working on 12.5. Oh.
You know, just because of that, I'm just going to go ahead and delete that 6. Or...
Okay, sorry.
Slash parentheses.
Oh, not... Come on, caps lock.
Huh?
12.5 and 6, but it's 1, 2, 5, 1, 7, so I want to do... So 1 from 7 would be 6. You're the one who brought it up. Gosh. Alright, so...
Oh, I just got it.
I think it was Ethan yesterday, talked about once I find the zeros, I can also use that to find... Well,
And your access.
yeah, where your axis of symmetry is going to be, and likewise then your vertex. So, when we look at this example in problem 5, everyone got notes, we're all good. We go through and we factor it. This is a pretty easy one. I get x plus 5, x plus 1. My zeros are negative 5 and negative 1.
Thank you.
Oh, and Emma.
Thank you, Brian.
Thanks, Brian. Oh, dang it. I knew that. Oh, nice.
Gravity
one,
works.
Hudson.
Calculus? Anyone? No, of course. You're too fast.
Oh, you said it.
I was going to come over this way and Brian was just too fast.
I gave that.
What are you eating?
A lifesaver. Because my mouth tastes weird after
Why
lunch.
don't you get some?
Brian.
You just got suckers yesterday. It's probably. Did you know what they smell supposed to not actually? Oh, yeah.
Yeah, I know what that is.
It's actually bad.
Can we move on?
I'm sorry. What?
So, we find our zeros are negative 5 and negative 1. What is the distance between negative 5 and negative 1? Quattro. So then, we average that out or find the center of that. So that would be 2, because we got to cut it in half. And we can either go to left from my higher point or to right from my lower point and find out that my axis of symmetry is going to happen at x equal to negative 3. From there, I plug x equals negative 3 into my original function. So, our function was...
Or you could average the zeros.
Or...
For like a faster.
What do you mean?
Add them together and divide by 2.
So what? Yeah. So what I'm talking about is finding our y value now.
Well, right, but I'm saying like if you just want to do one step.
Okay. Yeah. So we need to find the average point of the zeros. We need to find the center point, axis of symmetry. However you want to do that, up to you. We plug our negative 3 into here. Negative 3 squared would be 9 minus 18 plus 5. So 9 minus 18 would be 1 plus 5 would be... Sorry, I was thinking 19. 9 minus 18 takes me to negative 9 plus 5, negative 4. We find our vertex point. From there, because I have 3 points, like imagine we only know this, this, and this. We can still make a pretty darn good parabola, even just having 3 points. If you want a 4th and 5th point, easiest thing to do is bump 1 right or 1 left of your zeros. So either go to your negative 2 or your x equals 0. Whichever one I want to plug in, I can find a couple more points that'll help me make the parabola. If I plug in 0 here, I'm going to get an output of 5.
Wait, I'm confused with the negative.
You're confused, what? Where we got the negative 4?
No, like I know how we got negative 4, but what did the negative 4 do?
Gave us the y value of the vertex.
Oh, okay.
So now I knew that when x was negative 3, y equaled negative 4, and that allowed me to plot my vertex.
Okay.
Any other questions? Sorry, I'm moving kind of fast.
Okay. Yeah. No, I get it.
So once we plot that vertex, we've got our 3 points, the 2 zeros and the vertex. either, depending on how far your vertex is away from your zeros, if this was a really big distance here, I'd probably want to move in towards the vertex to find another, like a set of points. But it's not that far, so plugging in 0 makes it really easy. I find my 5. I know this is symmetric, so I go the same distance away from my axis of symmetry, and then I'd be able to make a very good graph. So that's how we manually make a graph of a parabola. Any preguntas?
That's question.
That is questions in Spanish.
Oh, wow.
So just so it's in the capture notes, we went from here to here, and then, yeah, they don't even go as far as I went finding the 4th and 5th points, but if you want to draw a good looking parabola, I'd advise you to have 5 points. Vertex, pair, pair. Also, quick way to find your axis of symmetry, or the x value of your vertex, negative b over 2a. We talked about this probably over a week ago. It was only a couple sections ago. But negative b over 2a is part of your quadratic equation. It will help us find our values. So that's all in your notes. So let's try the got it. Factoring this is your first step to find your zeros. We have no coefficient on the x, so that's nice. We start with our x and x. I have a negative constant, so that tells me what about the arithmetic inside the binomials?
The big thing is negative, and the smaller number.
So I've got a positive and a negative, and then the stronger one is the negative. So then what values, what factors of 5 could I use to sum to negative 4? Negative 5 and a positive 1, which makes my 0 points five and negative 1.
That's it.
Well, not quite. Well, okay, so it only asks for the zeros, but if we wanted to find the vertex, we then need to average out those points to find my x value. Sorry, something got in my eye. Find the x value of your vertex. So where on the x-axis would your vertex fall? Yeah. 2. Which is what Calvin was talking about. We could just average, like literally add them and divide by 2. So if we add those, we get 4. Divide by 2, we get 2. So my vertex... Come on, smart board. I can plug positive 2 in. I get 4 minus 8. Takes me to negative 4. Minus 5 more. Get negative 9.
How do you get that?
So I plugged in 2. So 2 squared is 4. Minus 4 times 2. Minus 5. Any questions? Then if we wanted to graph it, we could find a couple more points by plugging in any x values that we want. Here, I'd probably advise you to plug in like 0, because it's in between your vertex and your one of your zeros. So if I can plug in 0, then I'll find a matching point that is symmetric, and that's super easy. So at 0, I know that I have more points. When I plug in 0, I get negative 5. So that'd be another set of points. And there's a symmetric point on the other side. Well, if this was 1 in, 0 would be 1 in. So if I'm looking at the parabola like this, we have negative 1, and we have 5. So I came 1 in here and had negative 5. So I come 1 in here. So 4 would also be at negative 5. Because we know it's going to be symmetric. So I know these points, I know those points, and I know this point. Yeah.
What is that supposed to be?
An and sign. I know, I'm drawing it. So it's not even supposed to be an ampersand. I just make my and like that.
Oh.
Yeah, that's just, But I can, no? Where do you start for ampersand? Right side?
Oh, I used to know how to do this.
Yeah.
That
I started
is an
like,
ampersand.
I do that.
And then there's treble clef.
Oh, I do.
No.
No.
I think I went backwards.
Way off.
It's like a weird F. But yeah, any questions on how we find those points? Yeah, my handwriting is poor. That's not a question.
Okay, yours is the same. That was actually pretty fun.
And that's it for 12.5. So 12.6 that I just gave you guys.
It looks like it's like a blob. Yeah, basically looks like a ground.
Is Caleb also out sick?
Yeah.
Caleb, get healthy, man.
No, we're like all everybody's
It was
sick.
back in
I
the
was sick.
There's Kabila was out yesterday because he was sick.
Caleb was back in the back.
Can we just cancel
It's
school?
not for international peace, but he's so.
The plague.
Everyone keeps getting sick. Yeah.
So, your school has a field with an area of 8,400 square yards. We want to section out the field to run a variety of drills. So to do these drills, we need 2 square spaces, both x by x, and then we're going to have some rectangular spaces left over. And actually, if we cut it all up, we're going to have then some other small squares in the corner, because these would end up 10 by 10. So we want to figure out what the value of x is. So when we talk about area, we know that area for a rectangle would just be length times width. So we need to talk about our length and our width here. What are our length and our widths? Or width, singular. Carm?
Well, our one of them is 20 plus.
Yeah, if we call this the width.
X plus 20.
X plus 20 if we want to be nice and write the variable first.
And then we have 20 or 2x.
2x plus 20. And we know that equals 8,400. How do we do this? We did a couple like this yesterday with the picture frames.
Tinfoil.
So we could foil this. And when we do that, you want to walk me through it? First,
2x squared,
outer, inner,
20x,
20x, and
40x, so 60x,
so 60x.
and 400.
But then, this is no good because it's not quadratic. So we subtract our 8,400, and we get, sorry, I'm going to move over here, 2x squared plus 60x minus 8,000
Is 0.
is equal to 0. And I am out of board, but you get that. Michelle? Ooh, always, if possible, factor before you even start the process. So we can get x squared plus 30x minus 4,000. So now the fun that we get to have is what terms that multiply to 4,000, a negative 4,000, mind you, add to get 30. So we've got x and x. One's going to be positive, one's going to be negative. The positive wins.
Obviously 4,001.
Obviously, 4,001.
Is there an easier way to factor that stuff? Like, get to 4,000? Is there an easy way to do that? Or is this-
I mean, you can make a factor list and just like literally do every. But that's, I mean, it's more work, but it's less thinking. Megan?
80 and 50.
So we do, which is positive?
80.
Positive 80, negative 50. 8 times 5 is 40. With the 2 zeros, we get 4,000. The difference between them is a positive 30, or the sum, if you want to say that. Works. But what's that really mean for my question here? So my zeros are negative 80 and 50. I know. But the question I'm going to pose is, does that mean that x is 50? Because what about this 2?
The 2 divides from 0 to, and it just gets erased from memory.
What did we say about yesterday? That 2 only affects what of the parabola?
So, with the wideness. No. Yeah.
Yeah, the wideness, the like intensity. So it does change the vertex because it lowers or brings it closer, but it does not change where the zeros happen, so it would not affect my solutions.
If you pulled out a negative number, would it turn the parabola upside down?
Well, so we didn't really, like, saying pulled out, this isn't really gone.
Factored out.
Right, but like, so it's still there, so we wouldn't, like, us factoring this didn't change the parabola. If we forget about this, then it changes the intensity. So if we forgot about a negative, then yeah, it would flip it upside down. So, okay, then arguably it could change the intensity and the direction, but it still won't change your solutions.
Well, yeah.
Your zeros will stay in the same place.
Like, you keep changing the intensity to the point where, yeah.
Yeah, exactly, because when you change the intensity, you're changing where the vertex is what you're actually doing. Because we still go through the same 0 point, so if I'm closer, my vertex is wider. If I'm further away from the x-axis, my parabola is narrower. Any other questions about this? We get x has to be 50, because it's the only solution that makes sense. The 2 we factored out does not matter.
More hypothetical question.
Sure.
Could you factor out something that would turn the parabola into a line on the x-axis?
Not that it would actually turn into a line, but if you're asking the, like, could it look like a line, probably yes.
Because, like,
You have to
if it's
lay
not
it.
far enough, then it wouldn't look like a line. Well, I mean, because like if the vertex goes up and up and up, and if you go on the other side of the x-axis, then isn't there a point where the vertex could be on the x-axis?
So you're getting into questions that make more sense after we talk about leading the square.
Excuse this interruption. Could I have Jeremiah home to the office? Jeremiah?
So let's talk through this lesson and then talk about ideas like that. Because now is when we start to, like, okay, now, if I want it to work perfect, what if I just do this on both sides? And so now we start to manipulate and play with things. So yeah, hang on to that question. All right, so if we were allowed to make our constants whatever we want, we know that there's been some kind of horizontal shift that happened because we have a b term. So the parabola has been moved somewhere left and right, but we get to determine the vertical, kind of, because that c value is indirectly the determinant of the vertical. Question is, what would we choose to make it work perfectly? We would love if every quadratic was a perfect square trinomial, because then it'd make our life really easy. So if we know our b value, we are able to create perfect square trinomials by just taking the b value and cutting it in half, because that would tell us that if we had x minus 8 squared, well, that would be x minus 8, x minus 8. That would get, sorry that my 8 looks gross there, that would get my negative 16. Dude, I'm telling you, this is karma. I used to make fun of Mr. McCulley for that. So if we were able to determine our constant, the constant that we would have made would be 64. And if that c is 64, this becomes a perfect square trinomial. But that doesn't always work out, because we don't get to choose the constant. But we can play with things and make them perfect square trinomials. So, don't know how far we're going to get today, and the fact that we're missing a couple people. I wish we had everyone here to talk about this. So, check this out for a second. I'm going to reorient my board again. Decide what C needs to be in order to make that a perfect square trinomial. So you want to cut your B value in half to figure out what that constant in the binomial would be. And then we have to square it to get the C. And Strickland, you look bored. What's our constant?
Would it be 100?
So the constant we choose is 100. So this value in the binomials is,
I don't know, like 10?
yeah, because it's going to be the square root of that. I love when people say I don't know, and they then are going to directly follow that with the answer.
What if you actually do guess because you don't know and then you guess?
I sort of guessed, but it was like an
I
educated.
guess, sure. Yeah, see, educated guess.
It's like 106 or 100.
That's 0. It looks like an
Dude, so that's smartboard glitch. Watch me try it again. See if it does it again.
No, I think it was just you being quick.
Yeah, maybe.
Maybe it just did it
I've got
right.
some dead pixels. I'm trying to figure out where the dead pixels are, so if you guys ever see anything jump, like right where it's not supposed to be writing, let me know.
Oh, yeah, just color your whole board.
So moving on, we need to solve these quadratics. But not all of them are perfect.
No.
So, if we look for the solutions of x squared minus 14x plus 16 equal to 0, we're in quadratic form to start. But I can scoot my constant over to the other side and just look at my x squared minus 14x and imagine for a minute that that's where we had started and that we get to choose the constant. Because if we got to choose the constant here and make it a perfect square trinomial, we would again take your b value and divide it by 2 to determine that we would actually want x minus 7 squared would be ideal. That would be perfect. We would have a nice easy time, and that parabola is easier to think about, the shift that's happened. Because we talked, I think it was yesterday, when we have something happening in the parentheses, what kind of shift is that? It's a horizontal shift, and it's actually counterintuitive. So this would be right 7. If it happens outside the parentheses, that is going to be your vertical. So we say, okay, I would like the constant to be 49. But to do that, algebraically, to not break any rules, I have to add that 49 to both sides. Is everyone still with me up to this point? That we moved the value of 16 over, so it became negative 16. And then we think about what would be that perfect squared value. Everyone good? So then, on our right side, we combine our constants. So negative 16 plus 49, we get 33. This, we then can solve for x and find our zeros. But right here, my question for you, if I didn't have anything below this line, forget about like literally anything else that it says, what else do you think we could potentially do with that? If we subtract 33 from both sides, and this becomes x minus 7 squared minus 33 equals 0, no, that was a dead part of my brain because I'm not sleeping enough. My wife's in grad school, which means indirectly I'm in grad school. What do you think? I'm just helping her. I proofread. I'm staying up to help with stats assignments. Statistics is fun though, regardless of like it's hard work. It is fun.
That's what my sister says.
Stats is where math is like really applicable and really interesting because you can start to like learn things about society and groups of people or animals or whatever. Like it's just cool. What do you think this would tell us? If we said that something happening in the parentheses is some kind of horizontal shift, and what's happening outside the parentheses is some kind of vertical shift, right? Let's find out. X squared, I guess I should capture this, that'll make life easier. If we, use Desmos, hey, if you guys want to see your grades, I am almost ready to get back your 11 tests. I'd like to get them all back at the same time, so. X squared minus 14x plus 16. X squared minus 14x plus 16.
Ooh, yeah.
So, using the completing the square method, we can kind of cheat the parabola, put it into perfect square form, and at the same time, find your vertex. This is really, really cool. And I know I appreciate it more than you guys do, but nobody really showed me this method. Like, this wasn't that big or that well taught back when I was in high school. So, the whole issue of finding the vertex is not difficult regardless of what your parabola starts with. You can move the constant over, make it a nice, pretty, perfect parabola, and then just bring your other constant back into play, and you found your vertex. And then you can also find your zeros, and everything else just kind of all falls into place. And quadratics are much more manageable. So, let's try this. So the first thing to ask yourself is, are we in perfect square form right now? Half of my b value squared makes my c to no. So, no, we're not in perfect square form. So move your constant over and start getting it to perfect square form. When you move your constant over, I just go ahead and leave a space here because I know I'm going to be doing something on both sides. What do you think?
If you just want to add a constant, I think it's 20.25.
How'd you get that?
Half of the b value squared.
So, cut that in half to find out what value would have been in here, which gives you x plus, it's 4.5. If we made it a perfect square. So this can be, I should change colors, 20.25. And now my left side becomes that x plus 4.5 squared. And we took the route of finding the vertex because I'm kind of teaching ahead of us. But if we just want to solve it, then we leave the constant on the right-hand side. So if we combine these values, we get a positive 5.25. To get rid of the fact that my left-hand side is squared, what are we going to do? Square root on both sides. So this is going to become x plus 4.5.
Would you have a 5.25 in?
We combine these constants. Thank you for asking. Square root of 5.25 is not fun.
2.29.
Yeah, we'll just stop at hundreds.
Wait,
So
where did you get the 5.25 from?
we added these together.
Plus 20.
We're only chuckling because Brian just asked that. So here's the thing about square roots, though. Positive times a positive equals a positive. Also, negative times a negative equals a positive. So when you're thinking about the solution to your square root, you always technically, to be right, need to write the plus or minus, the positive or negative. So you said that was 2.29? With either the positive or the negative value. And sometimes, I had a friend in high school, and I actually now see why this would make sense. They would put the positive value on one side and put the negative value on the other side. And they would make a triple equation or a double equation, whatever you would want to call it. So this would just be the positive option. What do I need to do to isolate the x? Subtract 4.5 everywhere.
All 3 sides.
Yeah, they used to say all 3 sides and annoy. Sorry.
All 3 halves of the equation.
So now x, if you went the negative direction, will equal negative
6.79.
6.79. And if we went the positive direction, x would equal, still a negative, 2.21. So that also tells me that my vertex is negative, dead between those guys. Not easy to find. But we already know it's not going to be that easy because these already aren't integers, so it gets messy. Yeah.
Why do you add the constant to both sides?
So we cannot break algebraic rules. So what we did first was subtract 15 from both sides. That took us to this equation where these didn't exist. The red did not exist yet. We just had x squared plus 9x equals negative 15. We then wanted to say, if my left-hand side could be a perfect square parabola, then this side, where still the red didn't exist, will need to be a binomial squared. So we think about, well, if I need this constant to be half of my b value, because remember your outer and your inner are always really just going to double if they're the same, if it's a square binomial, then this value would have to be that constant squared, because your last does the constant times the constant. So if my left side was a perfect square trinomial, that would have to be 20.25. Now, unfortunately, I can't just make it 20.25. That would break algebraic rules. So to do that on the left side, I also have to do it on the right side. So we've now made our quadratic a perfect square trinomial, but it's not quadratic because it's not equal to 0. So we've just made a function that's equal to a value. It's not actually quadratic until we get it equal to 0, or we just go through the algebra and solve it. We don't have to take it through the quadratic method of factoring and finding the zeros that way. We can solve it just using the algebra. Good question. Because this is really weird. Like, the concept of completing the square is really awkward. And that's why over this past year I redesigned how I taught it to hopefully make this make more sense. Brian?
So the vertex would just be 4.5 and then 15?
So negative 4.5. Because remember, we always have to go the opposite sign of what's in it. And if we want to, this, and I think I'm actually starting to get you, Brian. Not that I ever didn't have you, but you're doing this stuff pretty quick.
Yeah, I like algebra better. I like geometry better than algebra.
This is both. So if I threw that in Desmos and did x squared plus 9x plus 15. Let it graph. Yep, that's why it broke. Negative 4.5. And, when you combine them together. So it wouldn't be the 20.
Oh, okay.
Yeah, because remember, we had to add the negative 15 and the 20.25. And when I bring that over, it'll be a negative 5.25 when I make it quadratic. So what Brian's talking through, if somebody's not picking up what we're putting down, is if our left side then was written as the binomial squared, it would be x plus 4.5 squared equal to that negative, or the positive 5.25 on the right side. But if I make it quadratic, I have to subtract that from both sides. So that would actually be minus 5.25 to make it quadratic. This is my horizontal shift that is counterintuitive. It's the other sign, so negative 4.5. And this is my vertical shift that does exactly what you think it does. So my parabola has shifted left 4.5, down 5.25, and we know where the vertex is because it's there. Your thought process was on. Just you didn't. Because if you wrote this out to actually do it, you would have had it. Any questions as of right this moment? We might as well. I've been keeping you guys up to / probably slightly over. I am not expecting you to finish this homework. I would like you to try it because it's weird, and I would love to take questions on this tomorrow. So please give it a shot and come to class letting me know what questions are hard or weird or that you didn't want to try because they looked scary. I don't care. Just if you want to go over any of these tomorrow, let me know. We will keep going through our lesson. But the first couple sections, at least, of this should make sense. I do.